This is the video for Lesson 7.2, Applying Exponent Properties Involving Quotients. You're going to find that these properties are very similar to the ones that were involving products. In this lesson, we're only dealing with two quotient properties. However, we're then going to put all the properties we've learned so far together. So the first property in this lesson is the quotient of powers property. And that says to divide powers having the same base, we're going to subtract our exponents. So if it was a to the mth power over a to the nth, we would do a to the m minus n. In numbers, if we had 4 to the 7th over 4 squared, we would subtract our exponents because we have that common base of 4, and it would just be 4 to the 5th power. So let's look at example 1. For letter A, we have a base of 8. Okay, we're going to subtract our exponents, and we end up with 8 to the 6th power. Remember that when simplifying powers with numerical bases only, we can write our answers using exponents, just like we did in the first lesson. In letter B, our base is negative 3. We're going to subtract our exponents and get negative 3 to the 6th power. In letter C, remember there's an invisible exponent of 1 whenever you don't see one. So our base is 3, and we get 3 to the 4th. Now in D, we have to do two properties together here. So first, we're going to look at the top. We have a base of A. Okay, this is the product of powers property. So we're going to add them together. We get a to the 12th over a to the 7th. And then we're going to use our quotient of powers property, subtract our exponents, and end up with a final answer of a to the 5th. In letter E, kind of similar to D, okay, we can say 1 times x to the 6th is really x to the 6th. And then if we simplify that, subtract our exponents, we get x squared. Now if there's coefficients in front of our base, when it comes to a fraction, when it comes to a quotient, we are going to simplify the coefficients. So the subtracting part only applies to the exponents, okay, but we're going to simplify the fractions just like we normally would. So looking here, I'm going to split it up into two pieces. Dealing with the fractions, 5/15 simplifies to 1/3. And then x to the 9th over x to the 4th, if we subtract our exponents, would be x to the 5th. Okay, and now you might be thinking, where are we going to put that? Well, if you look at it, there's more x's on top, so that means our x's would stay on top. And we know I don't like writing unnecessary numbers, so our perfect final answer would be x to the 5th over 3. In letter G, simplify your coefficients, then subtract the exponents on your bases. 21 divided by 7 gives you 3. 11 minus 7 is 4. And we have 3c to the 4th. Okay, try the guided practice. It should be pretty quick. So pause the video and replay when you're ready. Okay, number 1 should be 6 to the 6th. Number 2 would be negative 4 to the 7th. This here, remember there's an invisible exponent of 1. So on top, we'd get b to the 6th over b to the 3rd. And our simplified answer would be b to the 3rd. In number 4, we can change that to y to the 8th over y to the 5th. Subtract your exponents, you get y to the 3rd. And finally, in this one, simplify your coefficients. Oops. Subtract your exponents there. So 6/10 simplifies to 3/5. X to the 8 over x to the 5th would be x to the 3rd. More x's on top, so it's up there. Okay, our second property for today is the power of a quotient property, and you'll notice very similar to a power of a product property. To find a power of a quotient, we're going to find the power of the numerator and the power of the denominator and divide. So pretty much if there's a power on the outside of this, we're just going to apply that power to both the numerator and the denominator. So a over b raised to the power of m would be a to the mth over b to the mth. In terms of numbers, 3 over 2 raised to the power of 7 that 7 is going to be applied to both pieces, so it'd be 3 to the 7th over 2 to the 7th. Okay, flip over the page. So example 2, use the power of a quotient property. Once again, these are pretty quick. This one here, we're just going to apply the cubed to both pieces, so it'd be x cubed over y cubed. In letter B, it's going to make sense to stick that negative with either the numerator or the denominator. Really doesn't matter, but I think it probably makes more sense to stick it with the number, since that's what we're used to seeing more. Okay, and then we're going to apply that squared to both pieces. And notice I'm keeping that negative inside the parentheses. Over here, no negative, so it doesn't really matter if I write the parentheses. And now when we have numbers and variables, we need to simplify further. So negative 7 squared would be a positive 49 over x squared. Okay, so another guided practice. Pause the video, try them out, and replay. For number 6, all we do is apply the squared to both pieces, so it's a squared over b squared. For number 7, just like b up here, I'm going to stick that negative up with the 5 for now. When I split it up, that cubed gets applied to both pieces. Negative 5 cubed is going to be a negative 125 over y cubed. Now example 3 is putting it all together. Okay, so we've already used some of our product properties, but now we're going to use kind of everything all at once. Okay, and you'll notice that there's going to be different ways of doing these. Okay, it's not always going to be done in the same order. It's really your preference. Okay, for some of them, I will try to give you 2 different ways of doing it. Okay, but it's really your preference of what you want to do. So in letter A, okay, we have a power of a quotient. So I'm going to start there. So I'm going to say x squared squared over 4y squared. And you'll notice I'm breaking it up piece by piece, but eventually you might get really good at these and be able to skip some of these steps. Okay. Now here on top of the numerator, we have a power of a power. That was from the last lesson, so we're going to multiply our exponents together. That's going to give us x to the 4th. Okay. Here we have a power of a product from last lesson, so that squared is going to be applied to both pieces on the inside. So 4 squared, I'm going to break it up, but once again, you might not need to do this. So it's going to be 4 squared times y squared. So our final answer would be x to the 4th over 4 squared, which is 16, y squared. Letter B I'll do in 2 ways. Looking at what I have inside the parentheses here, first I notice I can probably simplify this a little bit first, because I have that x to the 6th over x squared. So I'm going to start by saying, well, this really simplifies. I'm going to keep my 4/5, but x to the 6th over x squared would really be x to the 4th. And now I can apply that cube to both my numerator and my denominator. So I'm going to say 4x to the 4th cubed over 5 cubed. Okay, now the cubed can be applied to both. Okay, so now 4 cubed is going to be 64. 4 times 4 times 4. X to the 4th to the 3rd, power of a power. Multiply our exponents, we get x to the 12th. And on the bottom, 5 cubed, that's going to be 125. And that's one way to do it. If you want an alternate version, okay, let's say you didn't notice you can simplify this first. You see this cubed, okay, power of a quotient, so let's apply it to both the numerator and the denominator. So 4x to the 6th cubed, or 5x squared cubed. That cube is going to be applied to both, so we're going to get 64 x to the 18th, if you multiply your powers, over 125. Multiply your powers here, x to the 6th. And now hopefully you realize you need to simplify your x's in the end. 18 minus 6 gives you 12, more x's on top, and we still arrive at the same final answer. Okay, in letter C, let's start by doing this power of a quotient. So I'm going to apply this fifth to both here. So 8 squared to the fifth would be 8 to the 10th. B to the fifth power is just b to the fifth. And now I'm multiplying these two things together. Okay, if you really want to write it out a little bit more, you can multiply your numerators, multiply your denominators, and I'm just going to write them in alphabetical order. Okay, some of you might be able to start reducing things right here, and once again, that is fine. And then the only thing I have left to simplify are my a's. So subtract my exponents, I get a to the 8th. That's going to be on top. And then 2b to the 5th is in your denominator. Okay, give the guided practice questions a try, and then replay when you're ready. Okay, number 8, looking on the inside, nothing to simplify yet, so I'm going to do the power of a quotient property. So 3a to the 4th cubed over 5b cubed. 3 cubed is going to be 27. A, power of a power, that's going to be a to the 12th. The denominator 5 cubed is 125. And then just b cubed. Number 9, nothing to simplify on the inside, so I'm going to do my power of a quotient first. So 2s to the 3rd over 3t to the 3rd, and then times that other stuff still. 2 cubed is 8 times s cubed. 3 cubed is 27 times t cubed. And then we're going to do times t to the 5th over 16. Okay, now look in here. I have an 8 and a 16. I can definitely reduce those. So my 8's going to become 1, my 16's going to become 2. And then looking at my t's, I have t to the 5th over t cubed. Subtract your exponents, you're going to end up with t squared. So let's put this all together here. On top, my number went away. So I just have s cubed. We decided with the t's, it's going to be t squared. On the bottom, we have 27 times 2. Remember that t got taken care of when we simplified, so 27 times 2 is 54. Okay, number 10. Okay, we have nothing to simplify, so let's do power of the quotient. It's going to be x to the 21st over y to the 7th times that other stuff. We can simplify our x's. So 21 minus 8 is 13. That's going to be on top, so x to the 13th. And then 3y to the 7th. Okay, example 4. Last example. I'm going to solve a multi-step problem. It says to construct what is known as a fractal tree, we begin with a single segment, which is the trunk, that is 1 unit long, as in step 0. We're going to add 3 shorter segments that are half unit long to form the first set of branches, as in step 1. Then continue adding sets of successively shorter branches so that each new set of branches is half the length of the previous set. Okay, so notice step 0 just had the trunk, then step 1 had 3 branches. Step 2, each of those 3 branches got 3 new branches. Okay, from there, each of those little branches got 3 more branches. And if we kept going, you can see that things would get really tiny and hard to see. However, we can make a table. So it says make a table showing the number of new branches at each step for steps 1 to 4. Write the number of new branches as a power of 3. So in step 1, there were 3 new branches. If we want to write that as a power of 3, that would be 3 to the first. In step 2, well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That'd be 3, oops, sorry. I want to say that 9 can be written as a power of 3 squared. In step 3, there would be 3 branches here, 3 branches here, 3 branches here. hopefully we're realizing the pattern that this would be 27 because it's 3 cubed. And in step 4, which we didn't draw because it'd be crazy, okay, the pattern would be 3 to the 4th, and that would be 81 branches. So now the question wants to know how many times greater is the number of new branches added at step 5 than the number of new branches added at step 2. Okay, so if we did one step further, step 5 would be 3 to the 5th power. So if we want to know how many times greater, okay, we'll do the opposite, we can divide. So we can say 3 to the 5th is what we're starting with. At the end, we want to know how many times greater is it than 3 squared. And using our rules we just learned, we can subtract our exponents. So that equals 3 to the 3rd. So we can say that at step 5, the number of branches is 27 times greater than at step 2. Okay, so just a recap of the 2 properties we learned today. The quotient of powers property is when you have 2 powers being divided. The power of a quotient property is when you have stuff being divided raised to a power. Okay, and once again, while we only learned 2 new properties today, okay, keep in mind that these might be mixed in with the ones from lesson 7.1. Okay, if you have any questions, please make sure you're jotting them down and asking them in class.